Hi, and welcome back to Stick Money, where we discuss all things related to finance. In today's episode, we're going to put some modern portfolio theory into action, because you're going to learn how to calculate and plot a mean variance frontier for a two-asset portfolio. And at the end of the video, if you watch right to the end, we're going to show you how the covariance, or the correlation between the two assets, impacts the shape of the mean variance frontier. This video is really targeted to undergrad students, master's students who are studying investments or finance, because I know that your professors will probably be teaching you the inputs of how to calculate a two-asset portfolio for a mean variance frontier, and then they're going to probably ask you to do some work, to do a project on it, some coursework, and then you're going to ask you're going to use Excel to do it. And I know back in my days, probably more than a decade ago, it actually took a lot of time to learn how to do it because I was starting from scratch. I need to brush up on a lot of my Excel skills to how to do this. But in the end, it's quite simple when someone shows you how to do it. And I wish someone did show me how to do it, because I would have then spent more time playing around with the model and understanding nuances and what the key drivers are. Rather than working out how to do a lot of things in Excel. But without further ado, let's get into the key learning outcomes. And you're going to learn, number one, how to calculate the inputs for a two-asset portfolio to create a mean variance frontier. And then you're going to graph the portfolio risk and return. You're going to learn also how to calculate those numbers. And then we're going to wrap up with some final thoughts. So without further ado, let's get into this. But first of all, I'll just show you the key things we're going to really produce at the end of it. Is one, this chart here, the mean variance frontier. I'm going to show you for a load of different portfolios the annualized return and the standard deviation by varying the weight between the two assets. And then right at the end, as I discussed earlier, I'm going to show you how to change the covariance between the two assets to get a correlation between -1 and 1, and then show you how that changes the shape of the mean variance frontier. So let's get into some calculations. So this item here, just ignore it, because that is the item where we're going to back out, change the covariance between area security and Bobo security, get a correlation between -1 and 1, and then we're going to show you, how the shape of the mean variance frontier changes. But let's get into some things. The first thing you're going to need is some security returns. So I advise you, you can use a number of sources here. Even if you're studying, you can go to DataStream, you can go to Yahoo Finance, whatever. Get some security returns. These are all made up by myself. So you've got area security and Bobo security, and we've got monthly returns here for the last 5 years or 60 months, and the same for Bobo securities. So let's calculate the annualized return for area security, which is simply equals average, and then you select all of the area returns here, and that's going to give you the monthly average return of 1.4%. And we're going to assume the past returns are going to mimic the future returns, which is very unrealistic. But remember, when you get this model here, when we've produced the end, I suggest you start changing these numbers and have a play about, because it can be very interesting. So that's the monthly return. You just times it by 12 to get the monthly return. So let's go and drag that across, and we see the average for the monthly returns for Bobo securities, and then we times by 12 is 5.9. So there's a big difference between the returns of these two securities. Now let's look at risk. We can just equal STDEV.S, because we've got a sample, and that's going to calculate the standard deviation. And all we need to do is, Excel wonderfully uses these function formulas here, and it will calculate it for you. So let's do this. Just select all of the returns for area, and then close the bracket, and that will give you a monthly standard deviation for area security of 4.3%. And to scale standard deviation is simply you're going to times it by the square root of 12, as it's 12 months in a year. And that gives us a 15% standard deviation from area security, and slightly lower Bobo security standard deviation is 13.1. So that's the risk and return for the securities calculated. Now let's calculate the variance covariance matrix. And if you use covariance formula here, if you do it with itself, area security itself will be the variance. So these two will be the variance, and this will be the covariance between area and Bobo security. So let's calculate these, the variance covariance matrix, which you can just go covariance.s, open bracket. Your first array will be area security. I suggest you fix these F4, put dollar signs on both of them, and then you'll select area security monthly returns again, but don't fix it because you can drag it across. And one thing we've got, we are annualizing here. So if you want to know how to annualize covariance, it's just timesing it by 12. That's simple. Now let's just complete this for the rest. Covariance.s, open bracket. We've got Bobo security, so and I fix that F4, and then you're going to choose the area security monthly returns array for your second, and there you go. And you're going to times it by 12 because we want the annualized. And there you go. So these two are the variances. I'll just highlight those. And these two here was the covariance between area and Bobo security. Now you can check this. This is quite simple. If you do this squared, so you would get those two numbers. You can see, let me just show you, this will equal this. So that's the variance. So if you square the standard deviation, you get the variance. And there you go. You can do it another way. You can go var.s, and then let's choose var area security. That gives you the monthly, and then we just times it by 12 to annualize it. And there you go. You just drag those two across. So there you go. That matches up with that, and that matches up with that. So now you know there's a variety of ways of doing it, but there you go. There are easier ways. I think once you get more asset classes, I did a video on a free asset portfolio and more, and that's when you can use matrix multiplication, which is going to make it much easier to calculate all this, rather than you doing equal covar.s and then doing all this kind of stuff. But I won't do that for now because I think we're only doing 2 asset portfolios, and it's nice to do this in the slow way. So let's calculate the portfolio, annualized return, and risk. So go equals, open bracket, and then we're going to take the area security weight. Weight. We don't fix this because we're going to, as we go down, we're going to change the weights as we go, and then we're going to times it by the area security return, annualized return. And then we are going to close bracket, and then we're going to plus, because it's just a weighted average return for the portfolio. And then we get the security Bobo security weight, and then we're going to times it by a Bobo security return, and we're just going to fix that because that's not going to move. And then we get a 5.9, and that's expected. So a quick check here is to say, well, if we're 100% invested in Bobo security, it should equal Bobo security return. And then we can drag this down right to the end. Oopsie. Let me just go down a little bit. And so if we're 100% invested in area security, we should get a 7.1. And there you go, you match up that 17.1. Risk is slightly different. So what we're going to do here is we're going to go equal SQRT bracket. Now what we're going to do is the weight of area, square it, and then we're going to times it by the variance of area, which is this number here. We're going to fix that because that's not going to move. And then we're going to plus, and then open bracket, the weight of Bobo security, square it, and then times it by the variance of Bobo security, which is here, and we're going to fix that. And then we're going to plus, open bracket, 2 times the weight of our security times the Bobo security weight, and then we're going to times it by the covariance between area and Bobo security here. And we're just going to fix that. And that will give you the portfolio standard deviation. And it's 13.1. Now, let's double check that, because if you're 100% invested in Bobo in this point, you're going to have the same risk as Bobo security, and that's 13.1. And you can just double check all the way down as you drag it. Ta-da, let's go. Wow. Oh. Now, let's see, if we're 100% invested in area security, we should get the same standard deviation for area security is 15, and that is 15. And you see the return is 17.1, so those two numbers correspond. Now, what we've done is, now what you're going to do is just create a chart. Now, you're going to go Insert, and then you're going to create a scatter chart. And now what you want to do is ensure that your Y range is the returns, which is here. So select all those, make sure the Y range is the returns, and then your X range is your risk or standard deviation. And then you get, ignore this for now, this is where we're going to show you changing the correlation between area and Bobo security. What's the impact in terms of the shape of the curve? So this is what you get. And so if someone's asked you how to do it, now you know how to create portfolio risk and return chart, changing the asset allocation between the two assets. So it's quite simple. Now we want to move on. So this is the original here, is to then say, as a bonus here, is what happens when the covariance between area security and Bobo security change. And we're going to do some, I guess, some variation from -1 to 1 for the correlation. But so let's look at here, and I'm just going to drag this item down here. But as you can see, I'm just going to delete that and just say 1. Now what I'm going to do is I'm going to times this by this number here and fix it. And the same here. So as I change this number, I change it to times by 50, this number is changing. So I'll just show you, just watch this number. As I change that to 1, it goes back to the original. Right. So what I'm doing is I'm changing these numbers here, but then what I'm doing is I'm backing out from the variance covariance matrix the correlation. So first of all, I'm going to show you how to calculate correlation. So if you go correlation on the original data series here, correl of area to area is always going to be 1, and then correl to area and Bobo is 0.0040, which effectively is like nearly a 0 correlation. So when we look at this chart here, this is the kind of the mean variance shape of the curve when we have correlation very close to 0. So what I'm going to do here is what I'm going to show you. So you can change the covariance between area and Bobo, but it's easier to standardize it into correlation. So you go to say -1 or 1. So let's get the correlation to 1. So you simply do this. So you've got the covariance, but if you divide it by the standard deviation of area and Bobo, you will get the correlation. So the covariance between area and Bobo equals the correlation between area and Bobo times the standard deviation of area times the standard deviation of Bobo. So to convert it, the covariance, your new covariance between area and Bobo, all you need to do is take that number and then divide it by the standard deviation of area, which is square root of the variance of area, times the square root as the variance of Bobo, or the square root of the variance, which is the standard deviation. So covariance between area and Bobo divided by the standard deviation of area times the standard deviation of Bobo will give you the correlation. So as you can see, they're pretty much the same because we've got no difference here. But if I say I put this to 50, say, then as you can see, this number, I just highlight it, will differ from this number. So this is the original correlation matrix. The correlation between the two has nearly 0. But if I change this covariance between area skew by changing this number, I'm then getting a new correlation between the two assets. So hopefully that makes sense. But what we're going to do is we're going to go to data. Unfortunately, when I record this, you don't see the solver. So if you get a solver, and I'll walk you through it, but you won't be able to see the solver parameter box pop up. But it says at the top, set the objective. So you want to change this correlation between Bobo, area and Bobo to 1. So if you, the next block down 2, your value of, and you put equals 1. And what you want to do is change, the changing variable is this here, because that's changing this number. If you put that in as your changing variable and solve it, it will change this number to impact this number here to make sure this correlation goes to 1. Hopefully that makes sense. And then because we've got all the formulas here, we know the risk and return of the portfolio. So what we're going to do is going to sneakily copy this and paste values here. So this is the paste values here, and that's now we assume a correlation of 1. Now to get a negative correlation of 1, so we just need to really put a negative side in front of here, and you'll change this area Bobo covariance, but that will change so you have a correlation of -1. And then let's just take those risk and return numbers, and as you can see, we'll show you quickly that they are different. So the returns will be the same because they're weighted average of the annualized returns, but you can see the risk will change. So let's highlight these two here, and you see, let's pick a point here, you know, when you had like 85% in Bobo, 15% in area, you had a 13.4% when the correlation was 1, but when the correlation moved to -1, it was 8.9, and that will show you how the shape is of the mean variance frontier changes. So let's just do one more, and I want to do a data solver, and what I'm going to do is I'm going to change this thing, this correlation here. So they set the objective. I want to do that to 0.5 to show you how it would do, and then let's enter. So this number changes to give us the correlation 0.5, and then we're just going to copy these and paste. Remember to paste special these numbers. And there you go. And obviously you can see, you know, if you take here, the same returns, but the risk changes based on changing the covariance. So, and if you standardize the correlation between area and Bobo. So what does that produce? It produces this chart here. So you can do, you know, a scatter chart and then put all these in. So your returns as your y-axis and your risk, your standard deviation as your x-axis. And then what you can do is you come to this chart here. So I'm missing one, so I'm just going to put that back to 1. So that'll give us back to the original covariance between the two, which is nearly 0. And so we can see, look, here is how it all changes. So if we had a correlation between Aria and Bobo of 1, you see this is our original as the green, but actually what happens is it becomes a straight line. It just connects to these 2 dots as we go along. Now if you have a correlation of 0.5, this one here, this brown kind of thing, it then becomes, it gets a bit more, bowy here. And then with a correlation of 0, it really bows out. But if you have a negative correlation, this blue line here, it becomes a triangle kind of. Amazing, huh? So, when you're playing out, what I suggest you and why someone find for is play around with this. You've got change your expected returns in the portfolio. Other things are inputs, so capital market expectation for these 2 assets may change, and you can change these numbers, and you'll see all this chart changing. You can add different probabilities, and you can do scenario analysis and so forth. You can change the variance of these assets. Wherever you say, look, you can change here. You can change the variances and see the impact. Obviously, for the returns, it's just weighted average. So the higher these returns, the higher the returns are going to go, and depending on the difference between the 2. But on the risk side, the standard deviation, the key drivers here are, your weights, the variances, the covariance between the asset classes. So as you change these, you'll get a different kind of chart, and you'll see all these changing here. But one interesting thing that I like to do is to change the covariance or the changing the correlation between the 2 assets and seeing how the shape changes. So as you can see, as the assets become uncorrelated, you can reduce the risk a lot. So it's, here it just really changes the shape a lot. So that's why a lot of people are looking for, assets that are uncorrelated in their portfolio, because they can reduce the risk for a given amount of return. So I mean, if you're here and you pick a portfolio here, if you get a negative correlation to the 2 assets, you can really up your return for the same amount of risk, or for the same amount of return you can get a much lower risk portfolio, if you can see. And it depends on these correlations between the assets. So that wraps things up. Hope you've enjoyed that. I've learned a few bits. So if you enjoyed the video, please click the thumbs up. And if you want to watch more videos like this, then please subscribe. Have a wonderful day, and I hope you learned a lot here.